Hello friends, welcome back. Sorry for the delay, but we're here on day 11 and we're still working towards getting this Fibonacci function to work with our little compiler. And I think we're very, very close. We did if statements or if expressions, and we need operators. So we need this equality operator and the plus and the minus. So we're going to work on that in this video, and I hope you'll stick around. So I suppose we could do the compiler spec first. We could say that right around the method call stuff, let's copy this one and stick it here. Nope, not that one. Maybe just something simple, something. Maybe this one. Method definitions. It compiles operator expressions. Okay, and let's just do 1 plus 2. And what that's going to look like is this will be an int, and this will be a push int, and this will be a 1. And then we're going to do something similar with the 2. And then let's get rid of all of this. And we'll say this is a call to the plus method with 1 argument. So at this point, I need to decide if I pretend that that we're doing what Ruby does, where you have a receiver and the plus method is called on the receiver. And so in Ruby, this is actually, one calling plus passing the argument to. It's really more like this, right? So if this was a word, it'd look something like that. So I need to pretend one way or another how, I need to decide one way or another how this is going to operate in my language, because I can do whatever I want. I think I'd rather pretend, even though internally when it's running through the VM, we're going to call the plus method on 1. I think I want to pretend that this is actually just a function that takes 2 arguments for now. I might have to change my mind on that, but for now let's do it that way. So let's say that's what we want to compile. Key error, key not found plus, because we don't know how to compile plus. And compiler. So we're going to need a couple things. We're going to need a built-in method dependency, I believe. Where is that? That's in the method dependency. So I could either put it in here, or I can make a separate built-in method dependency. Maybe I just put it in here and I say built-ins, something like this, and not sure if this is how I want to do it, but we're going to try it like this for now. I'm just making it up as I go, of course, as I always do. And plus, minus, multiply, and divide. Okay, so those are the built-in methods. We're going to say this was here, I believe, line 18. So we're going to say if built-in equals built-ins name, then do something here, else do the other thing. Okay, yes. So we are in the right branch, and we're looking for the type, the return type of the method. Do I need... How am I going to denote the return type? This might be a little bit verbose, but it's going to be easy to read. Return type int. Okay, so this way we eventually we could affect the type of an argument. So if we had something like 3 plus x, and x was unknown at the time, we could say that, well, we know that x has to be an integer. We're not going to use that in this video or in this session. We're going to just forget that that's even there, but at least we have the place to put it. And for now, we're just going to use the return type. So built-in, if built-in, we're going to return the built-in return type. So let's see how far that gets us. Got us closer, except something doesn't match. Push int 2, call. What happened here? What happened? Why am I missing? Oh, I think I know why. I think over in the compiler, when I have a call method, I'm getting the receiver, but I'm throwing it away. So we're going to say args unshift receiver if receiver is not nil. That way we can pretend. So yeah, so this is right now I'm getting something like call. I think it's a lit 1 with a plus. Actually, I can just print this out, and then I don't have to pretend to know what it is. So if I print that out, we're getting a call. This is the receiver, which I was throwing away. So we're just going to pretend that's an argument, because that's how our parser returns it. So we'll just do this, and hopefully that gets us a little bit better. Yeah. Now we've got a passing test, and we can infer the type of the, well, it's not really inferred, right? We just hard coding the type of plus, minus, multiply, and divide. I think that's fine for now. What else do we need? We need equality. We need an equality compiler spec, and we'll do 3 equals 4. 3, 4 equals and 2 arguments. Okay, that didn't quite work because of my missing comma. Okay, key not found equals method dependency 21. Okay, so we need yet another one here, equals both int and return int. And yes, this is the point where you're going, well, what about strings? Are we ever going to have equality for strings? Yes. And we're going to need something a little bit smarter for that. I don't want to dig into that in this video. Honestly, not sure exactly how I want to do that. I think there's several different ways, but we'll probably have to look at the type of one or more of the arguments and then look up the proper equality here. So I don't want to get too deep into a rabbit trail, but something like we could have more than one here, more than one equality, and this would be stir, and return type stir. So it could look up the proper one, but for now we're just going to pretend that the only way to do equality is with integers, and that takes care of that. So now we need a VM spec. Evaluates if expressions, evaluates method definitions, variable set and get. Let's do it right here. It evaluates operator expressions. Code 1 plus 2 and 3 equals 4, just like we did over there. I should have copy pasted it. Expect. I guess I need to do these one at a time. Yeah. Expect, execute 1 plus 2 must equal 3, and then we'll do 3 equals 3 is true, and 3 equals 4 is false. And those are the tests I need to work with the VM. Key not found plus. VM RB 47. So this is where we're looking up the methods again. And I wonder if I need a list of built-in methods here as well. Oh, that's kind of weird. Built-in methods. I'm not sure if I like this, but we're gonna go with it for now. And this will just be an array. Plus, minus, multiply, divide, and equality. Key error plus not found. Okay, we're on 55. So here, you want to say if built-in methods include the name of the method, then we want to do something. Else, we want to jump to the new index of the method. So here we're not going to jump to any other index. We're not going to move the instruction pointer around. We're not telling the VM to really do anything. We're going to call into Ruby. Since this is a VM and we're running on Ruby, we're just going to call into Ruby. This is a little bit of a cheat because when we end up writing another backend, we're going to have to implement this some other way. But I think this is a good start. The question is, how does it even work? So I suppose that we're going to have to say args.first.send, and then we're going to push that onto the stack. And we're going to send the method name, instruction arg, with the remaining arguments, args1. That's the idea anyway. I don't know if that's going to work or not. We already popped the args. Yeah. That is great. That wasn't too bad. Very cool. Okay, so I was looking at this code, and I think there's a bug in how we're doing scoping. I think, let's see, what is it? Scope stack. Where do we ever add the scope stack with vars? We don't. Yeah. So when we're calling into one of our methods, so like here, we set the index, we're processing a call, we set the index, and then the next time through this loop, we're going to be executing the instructions inside of a method. We never set the scope stack. And so I believe that variables inside arguments inside of a method are going to stomp on each other. And so I want to prove that with a test. VM Spec. So now that we have some math operations, I think that we could probably prove this. Maybe right here. If I did b minus 10, should that return 90? It does work. Okay. Oh, but what if this was named b as well? What would that do? Okay. And then what if this returned b? Okay. Oh, no, that should not be 90. That should be 100. Okay, I think that we have a failing test. So I need to write this. I need to do this as a separate test, though, because I don't want to mess this one up. It does not stomp on method arguments. Okay, so if this is called b, and this is b, and I'm going to return the b, this minus 10 should not affect the return value because it should be the original 100. So this is immaterial to the return. So I need this to be 100 still. And so there's our failing test. That's what we need to get passing because this is going to cause us a lot of issues when we start calling Fibonacci recursively. So the fix for this, I believe, is when you're calling into a method, I think you need a new scope stack. Yeah, scope stack. Where do we do this? Here? So we need a new set of variables, and then when we return from a method, and that's the indef, I think we just want to pop that off. That's the idea anyway. We'll see. That didn't fix it though. Key error, key not found B, VM44. Maybe I only want to do this inside of our own methods, not for built-in methods. Does that get us closer? No. I think this is right. I think it needs to go here. Vars. Scope stack. So 44 push var. Vars is the scope. The last scope stack. Okay, yes. Just want to make sure I knew what that was. So we have a push arg, and then we have a set var, and then we have a push var. Interesting. So what have I done wrong? You're calling into a method. I may have to step through this one line at a time. Okay, VM Spec 65. So let's focus this test and print out some information about where we are. So it might be interesting to see the instructions as they are executed. So let's print the instruction. 2H, is it 2H or 2A? There we go. So here are, and let's also print the index, so we kind of know where we're jumping around, something like that. There we go. So we started at 0, and maybe we PP the instructions that map to H. Oops, that is not what I meant to do. So these are our instructions. That's going to be a little bit weird. So this is 0. 11 is def bar, so that's all the way down here. This is 11, and then we jump to 16, 12, 13, 14, 15, 16, which is the push string foo. I'm just going to single step through this, make sure I kind of have an idea. Push, and then push int, and then call foo, and so that jumps up to index 1, right, all the way up to here, which I guess to here. Push arg, set var a, push arg1, set var b, push int 10 minus 2, we call bar, then we jump to bar, which is index 12, we push arg 0, we set var b, let's go down, we set var b, we push var b, end def bar. So that's the return. Now we push var b. Fascinating. Why are we calling bar twice? Is that in our test? Are we calling bar twice? Come on. Get back over here. We're not calling bar twice. We're only calling it once. Fascinating. Okay, I did something strange here. Popped the stack here, yes. why would we call bar twice? Call, okay, so we did b minus 10, and we called bar. And then we return from bar. And then we pushed, and then we return from foo. And then we called bar again? I don't understand. End def foo. Where did that return to? So when we get to end def, we do call stack pop fetch return index. Call stack? Oh, call stack should only be for our methods, not for built-in methods. Okay. Ah, there we go. That was a problem. Yeah, so we should only affect any of the stacks for our own methods, not for any built-in methods. Okay, sorry about that. That's a boneheaded mistake. It does show that I need better debugging in my VM. Just printing out the instructions like that, ugh, it's gross. I almost need some sort of single step ability. Ooh, that'd be cool. I'll have to think about that. Maybe that'll be another video idea. So yeah, we got that working. I think we fixed the bug with arguments stomping on each other. That was super important. Let's add everything to the index except this Fibonacci file. And let's see if we have enough to execute the Fibonacci now. That's the big thing. Does it work? Does it work? Should I have a compiler spec for it? Let's say this is spec. Let's do the examples, and let's move fib into examples, and then let's make a spec for that. I would like to have a compiler spec for it. I think that'd be cool. It compiles fib.rb. And code is file.read, file.expand path, examples fib.rb, dir, bam, 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 and then we'll say expect compile code must equal something, must equal with diff. Do we need that? I think I'm going to copy paste this, probably. I don't actually remember how to copy paste in Tmux, so let's do it this way. Spec, and I'll copy paste like this. Come on, baby. There we go. Going to have to every time there's a closing curly comma, I want to replace that with a closing curly comma, new line, and then some spaces, and do them all. There we go. Sorry, you're gonna have to watch me clean up this code because I can't stand this at all. Let's change that. Change this. Let's substitute instruction. Something like that. And then the only other thing left is, there we go. That's the code I would write. And let's just look it over real quick. Fib. So this is the code we're trying to compile. So we have def fib push arg 0, push set var n, push var push int 0 equal. So this is comparing the n to 0. If that's true, push int 0. This all looks good. all the way down to the else. I just want to look at this real quick. Push var in, push int 1, subtract, call fib with that result. Okay, push var in, push int 2, subtract, call fib with that result, and then call plus with both arguments, both results of calling fib. Yes, end if, end def, push int 15. This all looks good. I think that is correct. Maybe that's a little bit weird to use the spec in reverse like that, but it does help with regressions, right? If something changes down the road accidentally and this starts producing different output, then we want to know about it. So I like having that spec for that reason, VM Spec. And so now, what if we did a evaluates test in the VM and execute code must equal, what should it equal? Let's do Ruby examples fib. Maybe I have to print it. Yeah, and with our VM we don't have to print anything. That's okay. 610. Very good. 610. That's what we want it to equal. Wait, did that work? No way. It did. It just worked. That was the most anticlimactic reveal ever. I didn't expect it to work the first time. Wild. And if I change this to 16, then it changed. Okay, it changed the compiler test stuff. What if I focus this? We get 987. Is that right? I mean, I assume that's right. Oh, it works. Oh, that's so cool. Friends, can't tell you how awesome that is. It's so fun to see something come together like this. Is there anything else I want to do in this video? I mean, I have some time. Could I make this work? That way it runs in both Ruby and our compiler, our VM. Because right now, anytime we execute some code, we just look at the last value on the stack. But maybe we could look at the result of standard out. Okay, so first, let's commit what we have here, or at least add it all to the index. Because if I screw this up, so anyway, that's the end of the main video. You can tune out. I don't think really from here on out anything is going to be super exciting. This is just going to be me hacking on trying to get the little print method to work the way I want it to. So I might be a little less talkative because I'm going to be focused. But that was, oh man, I was just so excited. That's the main content of the video. What might be cool is to have, let's do require string IO. And we'll say IO is string IO.new. I think you can just do new like this. And we'll say IO is IO. We'll pass in the IO object. And then we'll say expect IO.2s must equal the string 610 with a new line. Maybe that's kind of what, that's the API I want right there. And that's going to break the compiler as well. So we'll need a compiler spec fix for this. Key not found P. Could we, method dependency, could we go ahead and add that? Args. Yeah. It's a little, gonna be a little bit scuffed, but it can work. Return type of P. For now, we're going to say it returns an int, even though I think that's going to be a lie. And then we can go back to compiler spec and do something with this. So we call fib, and then we have one extra instruction. That's going to be an int, and it's going to be a call with P and 1. Okay, that gets the compiler spec passing, which I think is perfect, and VM Spec. This does not take an IO object, but we could work on that. IO nil. Stood out. Compiler new VM new IO run. And I know VM doesn't take that, but we'll work on that. IO stood out. IO. Key not found P. Built-in methods. I'm going to say P is also built in. And we're getting closer. The P method. I actually want that to be something different, don't I? Built-in. What if I just cheat? I say instruction else. If instruction arg is P, then I just kind of want to cheat here. We'll say IO dot. Can I call that P on that? I have to call puts. We'll try P first. Args stack. What does that give us? Okay, private method P. So what I could do is call puts. Let's just always just do one argument. First dot inspect. Oh, I don't know. So calling 2s on a string IO is not what I want. Maybe it's rewind.read. What does that get us? Undefined method read. You can't see that, but yeah, let's just focus this. Undefined method read for 0 integer. Okay, so maybe you do IO dot rewind and then dot read. And that passed. Okay, cool. Now, is there a less janky way of doing this? What if built-in methods was a hash and the key? Okay, sorry, I need to complete a thought. What if the key was something and then the value could be something to call, like a lambda, arg, io.puts, arg.inspect. Then I can move it up into here, so it's a little bit clearer what's happening. And if it's nil, then we just call through to the built-in Ruby thing. I like that a little bit better. So now we can do this. We can say this. Change this to a lookup. Built-in method. So if that exists, then we're going to. Oh wait. No. Key. Built-in methods has that key, and built-in method built-in methods. Look up the key. Then we're going to do it this way. Otherwise, okay, hold on. I gotta get that back. Where was it? There it is. This is just going to be built-in method dot call with the args, I believe. Does that work? No, not quite. I just have a syntax error somewhere. 32. What did I do wrong? Oh, I missed the parenthesis. There we go. That is saying that that's a private method for I/O. So I can't access the instance variable here. Well, I guess I'll just pass it in. Works for me. It's not as beautiful, but it does work. They'll always just have to accept an I/O. Fair enough. Cool. So now, if I run Ruby examples fib, I get 610. When I run our little program, we also get 610. And I think that's all I want to do in this video. Let's add all this stuff. Let's commit it. Let's say day 11. And that's it. Where do we go from here? We need some more code. We need some more code to run. Maybe we work on something with strings, because that was all math and numbers, integers. Maybe I work on a hello world or something a little bit more elaborate where we try to execute some string concatenation or something. That will make it more interesting, because then we'll have a plus operator for strings and integers, and our type inference will have to do a little bit more work. Also, I'd like to work on a different backend. I think that will really shine and show off our type inference engine and how it works, especially if our backend is having to write C++ or LLVM IR or something like that. So yeah, stick around. Hope you come back and hang out with me a little bit more. Thank you so much. As always, open to comments and suggestions and feedback, as long as it's fairly constructive. Appreciate you as always, and I guess I'll see you next time.